Overall view of the project was to demonstrate running a public shuttle service with passengers in a real-world city centre.
Alongside safety, alongside other criteria for success, I think cyber risk is a key criteria for us to address as well. I'm joined today here by my colleagues Barney and Gaidre, and we, amongst a few of the partners, we were commissioned a few years ago by CCAV to run a trial for an autonomous shuttle up in Sunderland, and the project is called Sunderland Advanced Mobility Shuttle, SAMS. And just to give you a bit of background, SAMS, amongst other, in that cohort of trials that were funded, one of the missions there was to make sure that this technology is commercially and operational ready. And one part of it, amongst other assessments and analysis, one part of it, of course, was to look at the cybersecurity risk assessment for such an operation. And this is over and above the usual, the typical TARA type analysis for these risk assessments, because these vehicles are connected for various levels of communications and potentially control as well with the connectivity infrastructure. There is in the future potential comms with intelligent transport infrastructure, and there are other elements and interfaces alongside the vehicle and the overall system. So today we'll spend a little bit of time just to give you a bit of background on the trial itself as well. But then my colleague Gaidre is going to deep dive into the risk assessment methodology that we put together to demonstrate how we dealt with the trial. Now this is relevant also because if I could just say this, the overall concept, of course, is something that is increasingly being talked about in the media in terms of more trials, larger scale trials for various use cases on British roads. And the point here is that alongside safety, alongside other criteria for success, I think cyber risk is a key criteria for us to address as well. So the methodology as such is important for us to then have a mature process which helps vehicle providers with that compliance journey, but also then showcases some of the tooling and the concepts for us to have a mature process to address any such risks. Before we get on to the methodology, if I could ask Barney to come and join us and give us a few minutes on the overall trial as well. Thank you, Barney.
Thank you, Siraj. So overall view of the project was to demonstrate running a public shuttle service with passengers in a real-world city centre. So this was between Sunderland Transport Interchange via Sunderland University campus, and then to the hospital where it went past where all the ambulances, A&E was and everything like that. So interacting with a lot of real-world situations. Working with an operator, working with a number of providers to learn lessons and establish a business case for full commercialisation of this, and to be the foundation for further tests and trials with a particular ambition to move towards teleoperation. So partners, Angoka, Baldwin Networks, Communication Networks, Newcastle University, Swansea University obviously, Stagecoach, Sunderland City Council, and working with CCAV and Innovate, and the vehicle provided by OXA. So this is the route, really challenging route. This is there's a couple of videos around that you'll be able to see, or just have a look on the website. And you will see this is a really difficult route. One ways, narrow roads, having to go into the other carriageway of oncoming traffic, going across a five-way junction across the ring road, and a very difficult route. I've got to admit, I'm quite nervous driving it myself. And there was a couple of things that vehicle would do that, as a driver, I would struggle with. So we ran trials January, February and March. and with passengers, general public, in March. Within days of arrival in Sunderland, the vehicle was running autonomously, and it was initially with initial running with a safety driver and limited number of project partners and their staff before throwing it open to the general public. So over 1,700 kilometres of driving, some laps in 100% autonomy, the typical lap 96 to 100% autonomy, 600 runs between stops at over 99% autonomy, and some days impacted by roadworks where autonomy just dropped under 90%, which is what affected the overall statistics. One thing that's quite interesting getting into the vehicle is the first time it did the route, the software wasn't so familiar with the vehicle, and therefore the vehicle characteristics affected things. A bit later on, as you start letting people onto the vehicle, of course that changes the vehicle characteristics, and by the time we actually had passengers on it, and it was a heavier vehicle, then again vehicle characteristics were quite different again. So and the way the vehicle learned was quite impressive. So the vehicle provided by OXA, obviously they're primarily a software company, and retrofitted e-transit van. So e-transit converted to being a minibus and then converted to have autonomy with OXA's software. For those of you who might be interested, I think we were downloading 3 terabytes a day from its learning. First thing, technology was ahead of the legislation, and in fact our next stage is actually to work out how we can overcome all of the issues about O licenses. You know, we're talking about passenger service vehicle on a public road. The issues about the Highways Authority actually had no way of saying, yes, it's okay to go on there, but what they had to do was say, well, we don't object, even though the lead partner was the Highways Authority. Insurance and liability, I went around other projects that were running on the road, or due to run on the road as part of the same funding stream, and I asked the question, how do you actually fix the liability? Who's responsible in each situation? And a couple of them came back to me saying, yeah, we wished we'd asked that question at this stage as well. I thought, well, that's helpful. We did struggle with accessibility issues. It was a Ford Transit at the end of the day, and we will definitely want to go with a bigger vehicle that's low floor going forward. Get more people on it. EV, it was an EV vehicle, so 0 emissions. Fine for that route. We didn't have to charge it during the day, just overnight, but if you start going for the longer routes, that's going to be an issue. It was interesting with passengers. I spoke to one person who'd been on it 3 times, and by the third time it's just a bus. And then cybersecurity, especially as we get kind of more and more ability to control that vehicle off the vehicle and elsewhere, and that's a real concern, which is why the Swansea University were brought in very early in the project. So industry implications, we really have to move to L4 for public transport because economically it don't work otherwise. The importance of partnerships between industry, operators, network providers and local and central government, absolutely key. Diversions, you know, suddenly a water main suddenly bursts and your route's no longer available and you've got to do a diversion and you haven't taught the vehicle that route. So, the more we basically need to drive more and more on more alternative deviations so they can be learnt and then they can automatically be substituted in. Absolutely important, the communications and engagement with people. At one point in Sunderland, if you don't know Sunderland, the original concept of the vehicle showed a black and white 4D transit. thought that this probably wouldn't be a good idea to put Newcastle colours on a Sunderland vehicle. We didn't reckon it would last the first day, but in the end, people just kind of looked at it a couple of times, looked a bit askance when they realised it said self-driving vehicle, and then moved on. You know, people didn't actually bully it, which I thought was quite impressed about. So, Deirdre, over to you.
Okay, hello everyone. So I will just briefly introduce our methodology, and all it's after the lunch we do not want to hear too much of technical details and all the things we found. So this methodology was applied to SAM's project, but it's not a brand new methodology. So we used it for 5 years now. I think this is the 4th project we applied, and so the idea of a project is when vehicle is used as part of a bigger system. So we had autonomous trucks, autonomous cars, and this one, the SAM's project with autonomous buses. So, so very simple 6 steps. We start with defining the scope of analysis, so what actually we want to analyze when we build system model. We identify threats, we revise what results we get with threat analysis, then think of how can we reduce the risks if they are high, and then also what is our residual risk, if has it been reduced to a good level, and if everything is okay, so we go ahead and disseminate the results. So now we'll go just quickly through the steps. Okay. Okay, can you hear me okay? Good. So, yeah, like I said, first step is defining the scope. And we learned that usually it's a good idea to subdivide system into some parts, like we call it zones. And for several reasons. Sometimes system is just too complex, or sometimes it's not developed all at once. So for example, in these projects, we have a team developing a vehicle, and usually vehicle is developed first. Then we have another team taking care of the network. So if vehicle communicates with some remote operator, so we need a network to enable that communication. So the network comes next because we need to make deals with who will be providing that. And then the remote operator, remote station comes the very final one. So we found that it's convenient actually to analyze security of all these parts separately, and invent when everything is developed and tested separately, then we put it together and test as an entire system. So this is how looked the system for SAM's project, very high level architecture. So we had vehicle, which was our zone 1, and we have a 5G network, so the components of the network, and we had the cloud server. So that was our zone 2, and we had remote operation station, which was the 3rd, and finally the 4th zone that we put them all together. Now, before we start analyzing, we need actually to have some model of a system, which some kind of digital twin which represents the system. So for our analysis, we use structural model of a system, which we need to show main components, interactions, also assets. So what exactly do we want to protect? What is that asset, which security is important? And then also what are the security properties of those assets. Once we know that, we can go and do the analysis. Now, for threat analysis, we're lucky because we found a good partner. So we partnered with Austrian Institute of Technology, and we're developing this tool called ThreatGet. And what this tool can do is it can automate threat analysis. So basically, we just need to build system model, and we run the tool, we press analyze, and we get the long list of threats and the risk level already determined. So actually, it was a win-win relationship, I think, for both of us, because they allowed us to test the tool by applying in real life projects, and we gave them feedback, so that allowed them then to improve that tool. So this is just some screenshots from the tool. It has different stages, and it can give us the system model. It can, in the bottom, we see the table with a list of threats and risk levels, and we can play with things. We can modify things there, and even it can build attack trees, so to show attack path through the system if somebody wants to know the feasibility of the attack. And yeah, and it gives us this I ran too fast. So the main result is this table in the bottom, which says this is the threat on this asset with this type of security property, and this is the risk level. Now, it also exports all the results into Excel, so we can further play with it. And this is not the only threat analysis method we use, so the idea always is to use different methods to identify threats. So you can talk to experts, you can run another tool, you can do it manually. And then the variety of tools you use, so the more threats you cover. Now, anytime when we have this list of threats, we need to decide what to do with them. So either we avoid, or we try to reduce, or to share, or to accept. So sharing is very important in this type of projects, because when we have different parts of the system, so for example, we have vehicle developer, but we have network provider, and we have this remote operator, which sits within some organization. So then we can say, okay, this risk belongs to the developer, so the developer needs to think how to reduce it, or this maybe belongs to network provider, or maybe to the organization which will run the remote operation station. So we can assign it to all parties. Then what happens next? Then for those risks, when we said, okay, we need to reduce the risk level because it's actually too high, then we need to think of the risk reduction measures. But for us, when security team, we say, okay, maybe for us it looks like this and this measure is a good one for this risk, but we don't know actually how it will affect the system. So we need to talk to other teams. So first team we need to talk is to talk to developers. So developers need to tell us, is it feasible? Will it affect performance in some way? Is it too expensive? So basically we need to reach an agreement with developers that option is doable. Then the next very important team is to talk to safety team, because sometimes when we introduce some security measure, we can actually unintentionally compromise safety. So we need to make sure that it's all good. And then once we all agree on the measures, it's important step is that we need to add those measures into the system and run the analysis again. And why is it important? Because it allows us to evaluate actually residual risk. So we need to see if now, with this addition to the system, the risk is already acceptable. And yeah, so if coming back to this diagram I showed, so now we're in step 5. We identified those measures and try to reduce risk. And what happens if we cannot? So we run analysis again, it's still showing that the risk is too high. So of course we can try to select different measures and again agree on them and to see maybe those will work. But we could find ourselves in the station that we cannot reduce the risk. And then we need to go back to system modeling. So basically we need to go and redesign the system if we want to be able to reduce those risks. And if not, if everything is good, so we can go and finish our work and to disseminate the results. And yeah, I will let Siraj to explain this part.
So the project was quite a journey for us, and I'll show you the video of the actual route as well, which is the actual journey that Pani was talking about. But the journey I'm talking about is two key stakeholders, particularly for me. One is, of course, colleagues in the policy units and the wider kind of consortium and industry and professional community who, at every instance, we were engaged in the complexities of doing a risk assessment, understanding what the different kind of elements of the system are, what the scope of the system is, what needs to be factored into the risk assessment, and how, and what does that mean. But also then communicating those results as well. So the one commitment from us, beyond the scientific paper that you see, where we were looking at particularly the safety, security requirements and conflict management, is also we're going to be publishing some of the insights and also the methodology in a little more detailed way for other trials and other industry partners to perhaps adopt and then build further on. That's the one thing. The other key stakeholder for me was and is currently also students. And a lot of people who are coming into the industry either with an automotive or a control background or a comms background or a cybersecurity background, but getting them to perhaps come together across those areas of knowledge and kind of technologies, and to then address those needs for cybersecurity in the automotive industry. And so I'm very happy to say that part of the project's achievement was, of course, we went to the Royal Academy of Engineering for a visiting professorship, and Paul Woodison from Hariba Myra, I don't know if Paul's in the room still, but Paul's working with us over the next few years, informing our curriculum at Swansea, where we're using some of the trial and the wider automotive use cases as a key example for the students to apply to their risk assessment techniques. And I think that is important because, in a sense, I am determined, and we as a team are determined to make sure that there is a level of sustaining of those ideas and that activity as we go on beyond the trial itself, but also then prepare a workforce which can then deal with the future needs around this. If I could just ask the team to play the video, that would be great. Thank you. This is just a video that would show you the actual route as well. And Barney was talking about the complexity, but this is just trying to give you a little kind of a brief insight as to how we did the simulation as well around this for some of the risk assessment. And then beyond the project also, we'll preserve some of that simulation and the models for further analysis, but also further engagement as well. So very happy to take questions, but thank you at this point. Thank you. Yeah.